All right. So in case you skipped a few of these problems from the last ones, no, you shouldn't have skipped. You shouldn't have skipped. I'm not even going to bother addressing that. But there was no 4.4 because it's just a slide. There's three types of chemical reactions we're going to mainly focus on for solution chemistry, right? Solution chemistry is in dissolved in water. Now, there are three main types of reactions that we need to focus on. The first one we're going to talk about is precipitation reactions, which is a precipitation reaction is a reaction where a solid is formed. So you usually have, let's say you have NaOH reacting with silver chloride. All right. So both of them are dissolved in water, and they're both aqueous. So they're both aqueous, right? So precipitation reactions are two aqueous things when they react and they form either a solid or a gas. But in our case, we're mostly going to focus on solids. All right. So this is a double replacement reaction in which the sodium and the silver kind of trade places. Imagine that. But remember, they're all broken apart in water. So they're already separated. They're not stuck together. They're already just floating around in water together. So they switch places, and now you end up having AgOH after balancing the formula, right? And this one forms a solid, and then you form NaCl, and that one is still aqueous because salt water or table salt dissolves in water. NaCl dissolves in water. So since there's still water present, it stays as aqueous. However, AgOH does not dissolve in water. It forms a solid. It forms a precipitate. So that's what precipitation reactions are all about, is these types of reactions. And there's some set of rules that we must memorize and learn to use if we want to do precipitation reactions correctly. All right. So a precipitation reaction is a double displacement or double replacement reaction. All right. And a solid separates from the solution. This one, we did a lot of experiments like this, a lot of labs if you had me last year. So precipitate, the solid that forms. All right. Let's check it out. So here's a little visual right here of so if you have, let's say, potassium chromate, right? Potassium chromate and barium nitrate. Now, in these types of reactions, you have to remember that not everything is reacting. Only certain things reacted. In our previous problem, the NaCl didn't react. It looked the same. The Na was still floating in water, and in the beginning, it was floating in water. The Cl was floating in water in the beginning, and it was floating in water at the end. So it doesn't do anything. It just floats around, lingers around, doing nothing. All right. So you have to kind of trim the fat. You have to get rid of the things that don't do anything. And those things that don't do anything are called spectator ions. All right, so let's take a look at what products were made. Barium chromate. Chromate has a charge of -2. Barium has a charge of +2. So it balances out. And this one's a solid. And then over here we have potassium nitrate. And that's aqueous. Now, whenever potassium is present, did I say calcium? Whenever potassium is present, it's always going to be aqueous. So if potassium is present, it's going to be aqueous. If nitrate is present, it's always going to be aqueous. Memorize those. Anything in group 1, H, Li, Na, K, etc., all of them are aqueous always. Whenever there's NO3, aqueous always. So barium chromate is the only thing that formed a reaction, and that started with barium and chromate, and it made a solid. So that's the real reaction, okay? It's the real reaction. The spectator ions were potassium and nitrate. Just keep that in mind. Now, in the reaction, this is what happened. We have some things float. This is a poor visual. But let's say this is our barium, and then our our chromate were these. So that barium and that chromate kind of stuck at the bottom, and it made that precipitate. It made that solid at the bottom. And that's just what these reactions kind of look like. They form a solid, the little powder goes at the bottom. All right. So precipitates, or solids in general, they can be said to be soluble if they fully dissolve in water and they're aqueous, or insoluble if it becomes a solid. But things aren't just black and white. Things can somewhat dissolve, and then so they're slightly soluble or slightly insoluble. They kind of dissolve, they kind of don't. But we're not going to really focus too much on those. We will see them, of course, but just keep in mind that whenever it says insoluble, it's a solid. When it says slightly soluble, that means there's going to be something dissolved in there. And when it says soluble, fully dissociate. Fully dissociate. AQ all the way. All right. Now, there are solubility rules. What I highly encourage you to do, because I'm going to hand out, you should have a handout on these. Memorize the ones that are always aqueous. Always aqueous, okay? Now, I highly encourage you that. And I also encourage you to look at the substances that are usually solids, all right? There seems to be some sort of pattern, I'd say, right? There's a lot of similarities between these and when they form solids, all right? So keep an eye out for that. And then, I can't circle the bottom. There's a little thing missing, but hydroxides. Whenever you see an OH, you should be thinking this is most likely a solid. Whenever you see lead, you should be like, this is most likely a solid. All right. Just keep that in mind. This is a matter of practice, but it doesn't go away. So you must always, I would keep this solubility rules right next to your periodic table. Okay. Because if you can't find it on the day of the test, you're losing points. And eventually, remember, first semester, you can use everything. Second semester, donezo. All right? So, but just use it as a reference. Like, for example, I totally forget solubility rules all the time, but I have that thing in handy. So, which of the following ions for compounds with Pb plus 2 that are generally soluble? So, Pb plus 2 is usually solid, but when it's bonded to one of these, it's aqueous. Now, I said something about NO3. As soon as NO3 comes out, you should know it's aqueous always. As soon as you see anything from group 1, it is aqueous always. Well, why wasn't it aqueous here, Mr. Sanchez? I don't know. Take a look at its charges. Take a look. It's not going to be bonded with an Na+. It's only going to bond with something negative, okay? All right. So that's basically solubility rules. We're going to practice writing these equations on the next, whatchamacallit, section. All right. Peace out.